Okay, we're almost to the last topic we're going to discuss in this, and it's about drag. Okay, and so friction can exist in liquid, and it's what is known as drag. If any of you have ever had the thrill, and it really is, I mean, of hooking a nice like 2 to 3 pound bass um, in a pond on a light line, and then trying to reel that bass in. It's very fun. That the drag that you feel and the tug and all that. Even a bluegill is fun. If you want to turn a kid on to fishing, make sure you go to a highly stocked bluegill pond and you got plenty of small worms, and just throw it out there and just watch them go to town on the bluegill. It's a lot of fun. All right, but anyway, so drag. Drag has two components: viscous or skin drag. This is the friction between the solid and liquid surfaces, similar to kinetic friction, which is, we didn't talk about that too much. There's also pressure drag. The pressure at the front is greater than the pressure in the back. Remember that the force is equal to the pressure times the area. All right, so the pressure is greater. The pressure at the front is greater than the pressure at the back. So you get the force divided by the area. And so you got this drag formula. All right, you got this drag formula, and you're going to solve the drag formula for the Franz Klammer run, the infamous skier. Famous, very famous Austrians. The next two like little lecture pieces are, I guess, dedicated to the Austrians, because I got Felix Baumgartner doing a free fall and entering the drag of gravity, which we'll talk about, and we're also looking at Franz Klammer. All right, and you're going to calculate. Your last problem is you're going to use this formula to calculate the drag. What does the formula mean? This rho, this thing, that's the fluid of the air resistance, 1.2 kilogram meters squared. V is the speed that he's going. He reached about 80 miles an hour. They go a little bit. Bodie Miller, when he won his gold, was going about 81, 82 miles an hour. The coefficient of drag, which is a number that they came up with, I decided was 0.6 based on scientific looking up documents and what is the coefficient of drag of a human skier, because they do studies on this stuff. I mean, there's a lot of money involved in this. And then the surface area, the front surface area of the skier. Okay, V is the speed of the object in the fluid. CD is known as the drag coefficient. A is the front end of the cross-sectional area. You're also going to compute the Magnus force. Well, I'll get to that in a minute. If a bicyclist doubles his speed, okay. If a bicyclist doubles his speed, if a bicyclist doubles his speed, how much more force must he apply to overcome air resistance and drag? Okay, so if he doubles his speed, if you double this, so let's say he's going 3 meters per second, and then you double that to 6. What's the force? Well, 3, it was 3 squared, which is 9. If you double it to 6, that's 36. 36 is 4 times. You're going to need 4 times the force. I think I asked you that question in the thing. Drafting, skydiving. When a diver jumps, as he speeds up, this is what happens. He runs into this, and eventually he reaches, this is what happens when when you solve this for mg, when mg equals the drag coefficient, that is when, you're at the terminal velocity. That only happens in the atmosphere. So I want you to go ahead and I want you to do 2 things right now. I want you to watch the, let me finish this real quick. Skydiving, terminal velocities will vary based on body position, but you'll also notice that when Felix Baumgartner dropped out of the stratosphere ship, he actually went supersonic. He exceeded the speed of sound. Why? Because he's outside of the atmosphere. Okay? He's outside of the atmosphere. And this was the guy that was talking him down. So I'd really like for you to watch that. It's a fascinating. It's 8 minutes. Watch the 2 Franz Klammer clips. That's a total of about 6 minutes of your time, and then watch the eight minute um, the Red Bull clip on using the GoPro cameras on Felix Baumgartner. Cool stuff. Then we'll go look at your homework.